Alright, how's it going? My name is Jack. I'm the creator of Jungle. Welcome to the third tutorial / guide in my little temporary jungle videos. I don't usually make videos. These are a little awkward for me. But also, do know, these are very temporary because later on I'm going to make some really polished and well-edited tutorials, but for the time being, I really just want to throw these out there so that way people have a video to go, oh, that's how I do this, or this is how I do that. It's just so much easier for a lot of people. And me personally, I like watching videos over reading tons and tons of text on a documentation website. Although do know that the documentation is pretty good. It's available junglesequencer.com if you want to check it out there. Anyways, what is this tutorial about? Well, this is about, let me silence my watch, my bad. This is context and node customization. These are completely visual things for you as a developer, so these are what are going to help you develop faster, more intuitive, and it's just going to make everything a little bit quicker. So let's get into that. I've worked really hard to make some of these features as usable and as friendly and as cool as possible, so that way you as a developer can just kind of put them in, and then it just makes your life so much easier. I'll show you exactly what I'm talking about. Again, I'm going to create a jungle tree for the sake of the tutorial to just showcase what I did, and again, create and go right here. If I'm showing you how to do that, you need to go watch the first tutorial because you're already behind. It's actually really easy. So anyways, here's our tree. Let's go ahead and we're going to create a node. If you watched the creating nodes tutorial, then you already know how to use the fabricator, but essentially I'm going to go here and create a node, which I'm just going to call the what do we call it? The apple. Okay, it's fine. Tutorial. And then I'm going to make it red, and I'll give it an apple. Cool. Okay, I'm going to actually add some methods to try and show you some stuff. So I'm going to add the get details and the get progress, draw gizmos, and draw gizmos selected. Cool. If I hit next, I'm going to just do an identity node because I'm lazy. There we go, create. Now we have the apple node. Wait for it to compile, and then we'll throw this in. Apple. There it is. Okay, so here's our node. It's great. It sits there. It's nice. Works. I'm gonna edit the script. Let's go in. As you can see, Jungle went ahead and generated all of the methods, so we can start editing them. So I'm just gonna go ahead and close these since we're actually not even gonna run the node. It's actually completely unnecessary. And we're gonna get started with the edit details method. This thing right here. You can see right now it returns an empty string. What I'm going to do is instead I'm going to return hello world, exclamation point, save. Now if we go back to our editor, watch this. Whoa, it says hello world at the bottom now. Isn't that interesting? So what is that useful for? Well, what's really nice about that container, actually I don't need to make edits. Let's use the find game object node as a really good example of this. So if I game object name to cube, you can see it actually displays it at the bottom. So how is this useful? Well, when you're creating a tree, you do some kind of logic, so like this. Well, here's what's annoying about this. When pretend this details doesn't exist at the bottom and it doesn't exist here. You don't have that context to know what these nodes are doing since they're self-contained logic. So you'd have to go, okay, so start, all right, we're going to find a game object. Then you'd have to click it. Again, pretend that these don't exist, these little details down here. You'd have to click it and then go, oh, okay, it's going to find the game object by name cube. All right, it's going to get the transform. Okay, it's going to set its position. What position, though? And you'd have to look in here. You'd have to click. That's annoying. You shouldn't need to do that. So the idea with the details container is you can display the important information at the bottom of the nodes. So that way you can just go, okay, start, find game object with name cube, then we get the transform and set the position to 0, 0, 0. Okay, cool, easy. And what's really cool about this details container is it's dynamic, so it'll update as you change the variables. Right, pretty cool, right? Anyways, let's get back to our Apple example. So yeah, doing little things like that with the details container is pretty cool. I'm gonna add a variable. I'm gonna do a serialized field. I'll do a private string, and we'll say message. By default, I'm gonna have it equal to. Actually, we'll have it equal to nothing. I want to show you what that does. Return message. Okay. If we go back, you'll see hello world is gonna disappear at the bottom of our node. If I click it, we could change our message. Hey, and then if I get rid of it, our details go away. Isn't that useful? Here's one thing about the details containers. It can go pretty far, but it does have a limit, a very, very small character limit. Why would you do that? Why don't you make it go forever? Here's the thing about the details container. The details container should be something you look at for 5 seconds and understand information. If it's super duper complicated, then it kind of defeats the whole purpose. If you start to have tons and tons of nodes with these details containers, I mean, yeah, it works, but then it just gets really confusing, and it's just, the idea is you should just be able to look at it for 1 or 2 seconds, be like, okay, that's what it does, and then keep going. If you have to read a paragraph of text, that's just really slow. So trying to keep it shorter. If it ends up being a problem later in the future, I will extend the character limit, and also you can do that yourself because you have access to all the code, by the way. And yeah, so there is that. Just have that known. I think it's like 500 characters though, so you should have enough. So great, there we go. We have our apple with details. Okay, all right, the progress. Okay, what does progress do? You can see by default we're returning 1F, but we don't see anything, right? Well, here. We can use the wait for seconds node. It's a really great example of a node that uses the progress bar. So I'll go right here, and I'll set the time to like, I don't know, 20. You won't wait the whole time for it, but it'll show you. So, oh, go away, Apple. There we go. Okay, if I hit play, let's run our tree. Hello, thank you. Okay, let's hit play, and you'll see the bar starts going up as it goes, and from here to here it should take about 20 seconds. Well, it shouldn't take about, it should take exactly the amount of time that the node takes to run. So how do you do that, right? Is it just doing it automatically? No, that would be convenient, but I don't know how to figure that out. But yeah, watch this. So go ahead and I'll delete my no, bring my apple back up. Here's what we'll do. We can go in here and we'll actually create a serialized field, which we'll call private float do progress. I'm gonna also add a range here, 0F and 1F, and then let's, instead of get progress return 1F, let's return actually what the variable we created. And I'm actually gonna get rid of this up here to get rid of that confusion. Let's bring this up here a little bit. Okay, better. Okay, if I go to play, boom. Alright, now let me open up my inspector. So as you can see, the tree is not running right now. See? And I can set this progress, nothing happens. What? That doesn't make any sense. Watch this, I hit play, you can see the progress is there, and I can move it wherever I want. I can set to 100%. Notice how the node is still running. That's because this is purely visual, alright? It's purely for context. This progress bar does not actually change the node's, current state. It's purely visual. It's important to know. So you can do whatever you want. So if you want to like go up and then restart a couple times, you can do that. Do whatever you want with it. But yeah, you can learn to automate it, or not really automate it, but have it. Here's what we can do. We can make a simple timer if we wanted to right now. I'm going to create a serialized field, which will be private float duration. And then, hopefully I don't mess this up. We'll do a private float underscore start time. Then in the start method, we can do underscore start time equals time dot time. Okay, so we know that now. Let me move these above our two methods. Sorry. Set this equal to 1F, by the way. Then, what we'll do is, do if duration is greater than time dot time minus start time. We're just gonna bail, but if time minus start time is greater than duration, then we know that our timer has elapsed. We'll call and stop our node. Then here what we'll do is we'll just do how do you do this calculation? I believe it's duration minus I think it's time dot time minus start time, right? So this would be like 1 second, and then we take the larger time minus the start time. That would put it between that. That might not work the way I'm anticipating. I'm kind of writing this on the fly. Alright, let's just try it. If it doesn't work, it doesn't work. It's reversed. Okay, you can see the bar is visual. And, you know, we would obviously flip the direction of our function, let it recompile, and then try again. See if I can get this to work. For the sake of the tutorial. Oh, great. Yeah, maybe I'm just really bad at math, guys. But, let me reverse that. Yeah, just pretend this worked. But you did see the bar move. So that would be how you would use that. I'm gonna remove it. It's unnecessary. We don't need it for the rest of our, tutorial. But yeah, I do know you have that visual thing. Alright, then we have my favorite implementation in Jungle. This took the longest time to implement. This was a pain in the butt. Unity's Scene Gizmos system. They're super great, but they made them only useful inside of mono behaviors, which is like, why would you do that? And it's like, so I had to find a really stupid, you know, workaround to figuring out how to draw gizmos to the scene, you know, without a mono behavior, because these are nodes. So that's what you got here. So, you know, what you can do is you can do like gizmos, color set equal to green. And then I'll do gizmos dot draw cube, vector 3.1, and then vector 3.1. Now I go back to my game, let it compile. You can see, you can go to my scene view. If you make sure your gizmos are enabled, there's a green cube in our scene now. And you'll see it creates this little jungle gizmos object temporarily. That is what it is used for, but if I close the editor, it goes away. And if I remove that node, it goes away. If I bring it back, it comes back. But yeah, this can be useful in tons and tons of different ways. There is, in addition to that, the when gizmos are draw gizmos selected. And here I'll remove this for the time being, so I can more easily showcase this. So, for example, if I'm not selecting the node in the tree, then it's not there. If I do, it's there. Which can be useful, I guess. You know, just so you have it, there it is. Pretty cool. Wait, what am I doing? I think I actually want to show you guys a couple of actually useful gizmo systems before I, get a little sidetracked. Sorry. These are extremely unorganized tutorials. I told you. I warned you. Don't worry. I told you. So, example, here's a trigger. Let me find a better way to showcase this. So I can throw this at the bottom here. So here's my trigger node. As you can see, here's a visualization of the bounds of the trigger. So I can set the Y scale. I can set the X scale and the Z scale. And if I didn't have these gizmos, well, this is what it would look like. I'd have to figure this out manually. Like, okay, maybe if I do like this and I do like this, then it's what I want. How am I supposed to know that? So gizmos are really helpful in showing you exactly where something is, or its visual representation in the world. And that's all there. Or here's a sphere. There's a lot here. A lot. So that's where it can be really cool. Another one I know that is pretty cool is the follow path node, which I'm pretty proud of. And if you add points and move them around, I'll add another point. You can see it shows you a visual little thing. Can I do repetitions? There you go. So you can see now you have a lot of contextual information about your camera's path. So, your transform's path. So these are really good examples of some pretty stinking useful gizmos and where they can be super useful. Actually, if I bring back my follow path node, oh wait, I can't connect that to none. I'll go in here. Okay, so you see this fancy schmancy inspector that I have integrated. Isn't that kind of nice? So you can, edit them and stuff. It's pretty cool, right? Well, if I didn't have the custom inspector, it wouldn't look like this. It'd be kind of ugly. So how do you create these little custom inspectors for your nodes? Another good example, a much simpler one, is to find game object. You can see I indent the game object name. It's a little bit more obvious that this is like driven by this, for example. So giving yourself, again, a little bit more context about, what exactly you're doing. That's what custom inspectors are great for. So, oh, I bet they're really confusing and really hard to implement. You know, actually, I'm saying that sarcastically to be like, oh, they're super easy. They're a little bit difficult, but they work exactly the way that Unity's custom inspectors work for mono behaviors. So if you already know how to do that, you're golden here. This is no big deal for you. If you're kind of a beginner, there's a little bit of a learning curve to custom inspectors, but not to worry. I'll try my best to help you. But luckily, because it works exactly how Unity's custom inspectors work, there's so many people in the world who already know how to use this system that they can help you if you ask, you know, in different forums, etc. So just know I didn't create a completely brand new system for this. That would be completely pointless. Let's see, where's our apple? We don't have it in here, so we'll add apple back. We'll add a custom inspector. So currently this is what our inspector looks like. And you know, our inspector can generate automatically if we wanted. Well, it does already. So for example, just like Unity's mono behavior, we can add a serialized field. We can do private float number A. And, you know, also we can do public float number B. So we automatically already have that, you know, serialization visualization. But, you know, that's convenient. That's easy enough. If you don't want custom inspectors, no, you don't need to have them. They're just a convenience feature. They give you more context or help you to, you know, work with your nodes a little bit easier. But let's add a custom inspector. Here's the way I like to do it. Somewhere at the top, I do #if, I do Unity _ editor, and then in here, we do using Unity editor. Okay, what is this? You know, that's funky looking, that doesn't make sense. This is a script tag, so when your code compiles, you're telling it that it should only compile or add this to the compilation if we're in the Unity editor. Now, why would we do that? Well, when our nodes are built to our application, the Unity editor, namespace, the library, whatever you want to call it, does not exist. So you would have a compilation error in your code, which would make your build fail. So whenever you do something with the Unity editor, you should just do #if Unity editor. So we only compile our editor code inside of the editor, right? So we'll do another #if Unity editor. I'll do #endIf, like that. Simple. I'll do public class Apple node editor. That's just a naming convention I like, and I'll just do editor. That pretty much as simple as that. And I'm gonna do custom editor, and I'll do type of, and then the name of our node, which is Apple node. I'll put it right there. Control-C, Control-V, and I'll do on inspector GUI, which is this method right here. Tab, create it. Now we have it. So I can do is I can do GUI layout dot label. I'll do hello from the custom inspector exclamation point. All right, minimize that, and you'll see now there will be some text right here, hello from the custom inspector. And if you want to get rid of this little script thing, then you just remove this base.onInspector call, but I'll show you what that also does to you. So there, now we don't even see it. But here's the problem with doing something like that, which just makes it a little bit more complicated. For example, if we do like a variable that we can edit, private float number, you can see Unity automatically will throw that into our inspector like that. But if we get rid of this base call, just like this, well, watch what happens to our number. Oh no, now it's gone. It's because our automatic inspector drawing system that Unity has isn't working. So, okay, that's kind of confusing a little bit. It makes it a little bit harder to integrate, but you know, that's where you would, you know, you could, I don't know, you could do like var target or var apple equals target, and we cast it to apple node like that. You see, we're already getting kind of a little bit more complicated. We'll do apple dot. Oh, see, now we can't edit it because it's a private field, so we have to do public float. Now we've exposed. See, custom inspectors are a little bit complicated, but just trust me, they can be very useful in a lot of cases where you need to, you know, create some very custom stuff. But I'm gonna do it this method. This is my preferred method. I'll do a private serialized property. We'll just call it the _ number, and we'll do on enable _ number equals serialized object dot find property. It's called number. Hit that, and then we'll do editor GUI layout dot property field underscore number. And I believe you also need to do serialized object dot update, and then we'll do below that serialized object dot up. Where is it? I'm gonna try and find it right now. Apply modified properties like that. And now if I go back into here, you'll see we have our text and we have our number property, which we can, change and stuff. There it is. Now it's 2. We can hit Control-Z and it undoes it. So yeah, just like that. That's how you can integrate the custom inspector. I'm not really going to go into exactly how you make custom inspectors because there's already hundreds of videos. Go on the documentation. I linked a really good Brackeys video on it that I really like, and it explains it perfectly. But yeah, that's the context and node customization. Thanks for watching, and good luck.